objective here in this, or the last little category they have in this section, is called logarithmic differentiation, which we've already been doing some of this. Yeah. Now, the reason that we talk about this here is that they give us an equation. They say, look, check this out. What if f of x is equal to x to the third minus 1 raised to the fourth times the square root of 3x minus 1 over x squared plus 4? If we just started taking the derivative of this, we can do that, right? But that's like the chain rule with the quotient rule with the product rule. That would not be fun. It would be very tedious. Now, we could probably do it, but it would be ugly. A little slow going. That's exactly right. Yeah. But remember that we have all those LN rules that allow me to take an argument that's like multiplied and divided like this and pull it all apart and make it into something a lot easier. Remember that. Just give you a quick reminder. The ln of x times y over z becomes the ln of x plus the ln of y minus the ln of z. You remember that product? That was last year. And the year before that in Algebra 2 we talked about it. So I just want to remind you of that old property. And so if then I took the ln of both sides of this equation, right? Wouldn't it make it a whole lot easier if I could use that property and pull it apart and just find one piece at a time? So and I have the right to do that, right? The ln of the f of x is equal to the ln of x to the third minus 1 to the fourth times the square root of 3x minus 1 over x squared plus 4. Now I'm going to use the rule, the properties of LNs, and I'm going to rewrite that. That's the ln of f of x, and that's equal to the ln of x to the third minus 1 raised to the fourth plus the ln. Now, I'm not going to write that as a square root. I'm going to go ahead and write it as 3x minus 1 to the 1/2. Good. Minus, remember I subtract off anything that's in the denominator, minus the ln of x squared plus 4. And now remember, I don't have to have those exponents on those arguments, right? I can actually use the power property. And I have the ln of f of x is equal to 4 times the ln of x to the third minus 1 plus 1/2 times the ln of 3x minus 1 minus the ln of x squared plus 4. Now I have this, and it's in a much nicer form because now I can just take the ln of the derivative of each one of those ln's separately because they're all added and subtracted. Good. All right. So now when I take the ln of the f of x, then that gives me the derivative of f of x with respect to f of x. Okay? The derivative of f of x with respect to f of x. I took the derivative of it. Took the derivative of it. Okay? So it's what? Squared. 3x squared. Times 3. Over Excellent job. Okay? Yay, Emily. Now, of course, we are going to want to simplify that a little bit. Okay. We're going to have to. Okay, so if I simplify this, and I solve it for f, the derivative, right? I get f of x times so I've got the 4 times the 3x squared, and that goes in the numerator. Solved it for f of f, the derivative.
So, am I still going to have my 4 in there? Okay, so 4.
Wait. What's wrong, Jake?
I don't get how the f of x is from there all across the equal sign. You know?
Because I multiplied both sides by f of x to get rid of the denominator that was here. Okay? I multiplied this side by f of x so that that would reduce out, and then I multiplied this side by f of x. Okay? We're good. All right, good deal. So I've got the 4 and the 3x squared that are both whole numbers, so they go in the numerator. So I've got 12x squared over x to the third minus 1. Plus, how about 3 over 6x minus 2 minus 2x over x squared plus 4 is exactly right. Okay. Now, not exactly through, because I don't want to leave it at f of x. But what do I know f of x is equal to? That's exactly right. X cubed minus 1 raised to the 4th times the square root of 3x minus 1. Okay. And then I can just write all this stuff down. Okay? And that's quite enough simplification. Yeah, I'm doubting we'd be able to do anything with that. Okay? Don't want to do all that. Okay? So, now that you have the rule for finding the derivative of the ln, then a lot of those things that we've been fighting with doing the product rule or the quotient rule, we could now take the ln of both sides and actually do it this way. The only thing that you're going to have to remember is that when you take the derivative of the ln of f of x, you get the derivative of f of x divided by f of x, right? I mean, I kind of skipped that step and I just wrote it down, but you understand why, yes? Because the derivative of the ln of something is 1 over that thing, right, times the derivative of that thing. So I went ahead and put it together, kind of slid past it, and it messed Jade up a little bit, I think. Okay? So any questions about how we got that answer and how we could use it in the future? Instead of taking things that are nasty quotient rules and doing the quotient rule with it, I can take the ln of both sides. I can pull this nasty quotient apart so I don't ever have to do a quotient rule. Okay? Yeah, probably so. Okay, so your homework on this is on page 199. And I want you to do 9 through 78 multiples of 3.